Hi everyone, my name is Sadashiv and this is my submission for sprint16 and we are working with Vitalsync, the healthcare dashboard or electronic healthcare dashboard where we have the doctor and patient two modules right now. So before this sprint, Vitalsync worked fine as long as everyone used it correctly, like clean import, no crashes, no one trying to break through it. Right, that's fine for a demo, but it's not fine for a real product, right? This sprint is about making the app survive the real world, like the bad import, crashes, bots, accidental data leaks. So I didn't add the new features. This was a hardening pass on what already existed. So yeah, for beginning with the each phases of the sprint, we have two users logged in, one as doctor and one as patient on each of the different apps. So let's begin with the first phase. The first phase is about error handling and validation. First, I built a global exception filter. One file. This is one file that actually catches every error anywhere in the backend and always return the same clean JSON shape. Right. So if we see the response, so yeah, this is the response that our server returns: success, status code, message, path, timestamp. Right. So before this, any crash or any bad or any response from the server could leak raw internal details like file paths, database structure straight to the client. Now the client always gets a safe, predictable response where the full error still gets logged on the server sides for me to debug. Right. Um, so here show you the global filter, exception filter. Yeah, this is it, the global exception filter, the catch block. So alongside this, I hardened the input validation. I added the forbit non-whitelisted in the server where, yeah. So to the global pipe, I added this forbid non-whitelisted as true. So if a request sends a field that isn't supposed to be there, like someone trying to sneak in, is admin true? I'll show you that. On a sign up, the whole request gets rejected instead of silently stripped. Right. So yeah, this is one of the validation pipeline implementation I did. Now let us go to the postman and check whether we get the proper responses or not. I have the guide over here, what should return what. So yeah, let us open the postman. So we go from the, let us see if the admin, what we added just now, forbid were non-listed as true. Let's see whether it returns like request as right. Property is admin should not exist, right? So when we send this request, we get a 400 as bad request, and it says the message that property is admin should not exist, right? So if I try to remove this, let's see if it works right. Right. So it says email already registered. So on changing the email, it should now successfully store the user, right? It should return as created, right? So yeah, it's working fine. And the main thing was about understanding how the bad request comes when there is admin on another property that is created. So yeah, that is it. So this finishes our phase one. So now we have to implement our next phase two is on for the next phase we have the server side AI endpoint. So here I added the AI feature where the users can click on the generate AI summary on a patient's profile and it summarizes their medical history using Gemini. The important part, it isn't the AI feature. It is where the AI call happens. The front end never talks to the Gemini directly because anything in the browser is publicly visible. If I put the API key there in the front end, it is effectively visible, right? So it is instead calling the front end calls my own backend point, and only the backend holds the real key and talks to the Gemini. For example, if I try to inspect this and check if the API key is visible or not, it shouldn't be visible. It should be JWT authorized header bearer. So yeah, there is an error. I've been trying it out a little. So yeah, I'll debug that. So yeah, the main thing is here, the bearer, right? This is the token that is JWT authorized. So we don't have let's see if we also have it on. So we go on application. We see here. So here, so we know where we have the direct API key being leaked, right? So this is the JWT token as well. So yeah, that's the main feature that we had to implement. Um, on the code side, I'll show you how the controller works in the AI controller. Yeah. So these guard decorators, right, are basically protecting our API from being visible or being leaked. So this is how it protects it. And then we do have throttle. Yeah, this is where the rate limiting feature has been implemented, right? So if I continuously hit API calls for the backend, it returns the 429 error. I'll also show you that as well. So yeah, that brings us to the next feature of our project, that is rate limiting and log hygiene. The next thing I added was the rate limiting using the Nest.js throttler, right? So this should be here, right? So we need to have the Nest throttler. Yeah, this module helps us to implement the rate limiting in the Nest.js, right? This is to be specific. We have it over here. Yes. So if I take you to the postman and show you that what happens when I hit continuously to log in, it should return us 429 as this, right? So try once. First, it shouldn't give us any 429. It should give us bad request. On fifth or sixth request, it should give us 429, right? So yeah, if I try to do this for 5 times, let's say, right. So we can see that it changed from 401 to 429, right? So this is where the rate limiting happens. So if anyone tries to log in continuously, no, they will get this error and they will block all the requests. I also swept the code base and replaced every console log with Nest.js loader, Nest.js logger class. So nothing sensitive like request bodies containing patient data ends up sitting unprotected in production loss. So to test that, we have this thing, that is grep console log. Right. Let's copy and run this in a new terminal. So yeah, it returns a clean, like nothing is there actually. So which means that we don't have console logs anywhere in our code base. So yeah, overall, the predictable error handling, strict input validation, securely proxied AI feature, and rate limiting on the sensitive routes can clean clean production login. None of this has changed what the app does. It changed whether the app can survive real users and real abuse, which is really the difference between a student project and something production ready. So yeah, that was about it, and thank you for watching.